Chemistry lessons. Naming transitional metal compounds. Here's a look at a periodic table. Please remember that the periodic table shows us all the elements, but all of these down here in this blue area, blue-green area, these are what's known as the transitional metals. Now, these guys in here are also considered somewhat transitional, but not as much as the ones that are in the main D block in through here. Okay? The ones that are sitting in these columns, what we call the main group elements, and we've already discussed these. These are in the tall columns here, the main group elements. Okay? What we're going to be working on now is the transitional metals, which will reside in this area right here. Those are the ones you're going to be tested on. Now, as you can look at this chart here, here are only some, just a sample, and these are the ones that are found in row 4 of the periodic table. So as I look across here, I have a whole multitude of different charges that could possibly be on some of these different ones. Now, there's some that just have very, specific charges on them. Like, as we know here, zinc can only have a positive 2. Okay, as we can see here, zinc here can only have a positive 2. Copper is usually, we either have copper 2 or copper 1. Nickel is usually always somewhere in this 2 to 3 range, but occasionally could be a 1. Iron is usually always a 2 or a 3. Manganese can be anywhere from 7 to 2 in through here. And then chromium is usually in this 4 to 3, but it can have different charges. So there's really no way we can determine what the charge is on this unless we see the name or we read the compound formula. So it's not as hard as what it seems, although this is the biggest thing that most students miss on the first mandatory pass exam. They get this confused. So we're going to go through this, and you need to review this as much as you need to so this becomes solid. Now, if we look at the name, the names here are going to show us what we're combined with. So as you can see here, these are all combined with hydroxide, and we know that hydroxide has a -1 charge, okay? But the most important part here is that I want you to look at is that these Roman numerals that sit right behind the name of the metal, these are the things that tell us what the charge is on the iron. Now here's the mistake most students make. They will see, let's take iron 2 hydroxide, and I see this all the time, and they'll say, okay, I've got iron, and there's 2 of them, and I have hydroxide, so there, I must be done. And this is wrong. Okay, that is not what this 2 is supposed to be here. What this is trying to tell us is that we have iron and it has a 2+ charge, and it is combined with hydroxide, which has a -1 charge. So iron 2 hydroxide then would be written as iron 2 hydroxide. Each one of these are going to tell us what the charge is on this. So if I'm looking at this one here, that shows me I have iron with a 3+ charge. The hydroxide stays the same. So now I've got iron with a 3+ charge plus hydroxide with a -1 charge. So I'm going to have iron, hydroxide, and it's going to take 3 of them to balance out because the Roman numeral tells me what the charge is. And if I have to go to the name and I see this right here, like right here I see this iron down here and I know it must be iron 3 because there's 3 of them there on that, then I would write iron 3 just as it shows up here. And then of course this one here with the lead is going to be lead with a 4+ charge. Okay, so it's very important to remember the Roman numeral tells me what the charge is, and that's why we use it. Now, if I look at the compound formula, which we were just talking about a minute ago, here's the same compounds, and we're going to look at this. Normally, these are going to be combined with some type of polyatomic ion, but they can be combined with just a pure element like sulfur, phosphorus, oxygen, things of that nature, and then we would just end up with a different IDE on it. But here we're combined with this polyatomic ion. Now we know that the polyatomic ion, as we've already talked about, of hydroxide is a -1 charge. Okay? So if I look at this right here, and let's look at this one here, I have to determine how to get to this point and what the Roman numeral of that is. So I look at my compound formula here, and I know that hydroxide is a -1, and it shows that I have 2 of them. So that means I have 2 of these. I have a total of a -2 charge. I only have 1 iron. So what does the charge on that iron have to be? Well, it has to be 2 plus to make sure when I add those together I get back to my neutral charge. So I would write iron 2 because that's what the charge of that would be. If I look down here to the lead, and I just have the formula, only looking at the formula, I don't know what this is, I'm asked on a test to actually create this, then I would say, okay, hydroxide. We know hydroxide has a -1 charge, just as we showed up before. But now, as you can see, I have 4 of them. So that means I have a -4 charge. Well, how many leads do I have? It shows I only have 1 lead. So what's the charge on that lead got to be? It must be a +4. So when I add those together, I get back to neutral. So then I would write lead, and I would write the Roman numeral for 4. And then I would just write the name of my polyatomic ion or my element beside that for whatever my anion is. Now here's some practice. What I would suggest you do is you just press pause right now, go ahead and do these on a piece of paper, and then hit play again, and you'll be able to see if you got them right. I'm going to go ahead and write these down, okay, what the charge is on the metal and then the anion, and then I'll write the complete compound here. So lead 3. Lead with a 3 plus charge, plus nitrate, which is one we have to memorize, has a -1 charge. So I'm going to have to write this as lead, okay, NO3, and I need 3 of them. Now I have copper 2 sulfate. Copper with a 2 plus charge. I'm adding it to sulfate, which we know has a 2 minus charge. So those are both going to balance out, so this would just be written as copper sulfate. Now, I'll just write these down here, all so you can check your answers and see how we're doing. So iron 2 oxide, iron 2 oxide, okay, would look like this. Iron 3 phosphate, iron, and a phosphate, and then manganese 4 carbonate. We know that the charge on a carbonate is a -2, and this says I've got manganese 4. So I'm going to have 2 of these carbonates to balance this out. So I'd write manganese, then put my carbonate in parentheses, and I need 2 of them. Now let's go the other way. I've got the names, I got to create the compounds. So once again, I've got lead with a 4 plus charge, and I'm going to add this to nitrate, which has a -1 charge. So I'm going to need 4 of those nitrates. Cobalt with a 2 plus charge, because that's what that tells me. I'm going to add it to hydroxide with a -1. So that would be cobalt, and then hydroxide, and I need 2 of them. Zinc 2. So that's going to be zinc with a 2 plus charge, and once again I got carbonate with a 2 minus charge. Those balance each other out, so I would just be writing zinc carbonate. Now here I'm going to change colors here so we don't get all confused. I got copper 3, so that tells me my copper has a 3 plus charge, and then my sulfate, which we already know has a 2 minus charge. Now the best way to do these is, like I said, take this charge and put it to base over here, take this charge and put it to base over here. So I would be writing copper with a 2, sulfate in parentheses, and I need 3 of them. And then the last one here, chromium, Cr, and it says it has a plus 5 charge. I'm going to add that to acetate, which has a negative 1 charge. So I'm going to need 5 of those. So I'm going to write chromium, and then I'm going to put in parentheses my acetate, my polyatomic ion for acetate, which has my negative 1 charge, but I'm going to need 5 of them. Now it is very important that you go forth over and over this. You need to keep practicing this. This is one of the toughest things for the mandatory pass exam. Okay? Every year many students blow this, and it's not that hard as long as you pay attention that the Roman numeral is just a charge on the metal. Okay? That's all you need to do. Practice this as many times as you can, and if you have any questions, come in and ask them. Remember, chem is try, never ever give up, and stay gritty. Thank you.